Hi, everyone. Okay, so I just want to take a minute to remind you that not everything has to be a special value. These are really useful, and we're working on them a lot, and we're doing a lot of memorization, but we only know a very specific set. So the orange dots that I have marked off on my unit circle graphic here, that's all we know. We know the values of those points, and there are a lot, in fact, infinitely many other points on the unit circle, and they're all perfectly good points, and they're all going to come up in problems that you're doing. So just to get started, pause for a second and try to approximate where the point P would be if it's at the end of an arc length of pi over 15. Okay, so if you've done that, pi over 15, so we could either do this by getting an approximation of that on a calculator, or we could just say, well, we know that this is pi over 6 right here. Let me snag a pen. Pi over 6. And we know that if we cut that in half, that would be a pi over 12. So pi over 15 is going to be even a little bit smaller than that. So let's just say, I don't know, maybe around here. So that's approximately where I think my pi over 15 ends. And this is definitely approximate, but just trying to get an idea, a sense of what these values are. Okay, so if you didn't already, pause and now try and approximate the value of cosine of pi over 15 to see if you can figure out approximately what that would be. Okay, so I'm going to zoom in a little bit here. Remember, cosine is asking for your x value. So if I've approximated that this is roughly where my point P is, my x value is really, really close to 1. So according to my graph, this is 0.9. So this would be 0.95. So it's even bigger than that. So maybe 0.975, something approximately like that. So I'm going to say down here, 0.975. You can check this. So let's see, I think I have a Desmo set up. Here's the scientific calculator. You can also do this in the regular calculator. Just make sure, I'm sorry, the graphing calculator. Make sure that you're in radian mode. So you'll have to hit settings up on the top right corner if you're in the graphing calculator. Here it's this radians degrees, so make sure it says radians. And we wanted cosine of pi over 15. So to get that pi, you can just type pi or you can hit the button. So I typed pi. That's what you saw going in there. And then to get the fraction bar, you can hit the fraction button, you can hit the divided by, or I just hit that slash on my keyboard. And we can see it's about 9.78. I was actually pretty close. So I estimated it was about 9.75. It's really about 9.78, about 9.8 even if we round that off correctly. So pretty close. Okay, so try the same thing for sine of 1.8. Think really carefully about that 1.8. Okay, so 1.8, part of this is going to be figuring out where that lands. And there's the funny thing that happens that I've mentioned where we get so used to working with fractions of pi and multiples of pi that when I give someone 1.8, they sometimes get kind of tangled in that. So remember, it's not 1.8 pi, it's just 1.8. And a really good sort of reference point that I would try and keep in your head is that this is pi over 2. So that's approximately 1.57 radians. This is pi, so that's approximately 3.14. We're trying to go 1.8, so it's just going to be a little bit past that 1.57. So again, I'm not being perfect at all, but I'm going to approximate that it's right about there. And so that's my point P now. We were trying to estimate the value of sine. So remember, sine is y value. So I'm going across and I'm seeing kind of the same thing as last time. It looks really close to 1. So I'm going to say that it kind of looks like it's about 0.99 to me, the way I drew mine. That's definitely an estimate. And we're just trying to make sure that you have a good sense of how things are working on the unit circle. So back in Desmos, you can just type in sine. Let me show you as well, though, you can get these functions if you, right here above the above all of these things, oh, I guess sine was right on there, but you can also get a bunch of functions if you hit that. So your inverse, sine, cosine, and tangent will be there. So sine of 1.8 is about 0.97. So I was a little bit high this time, but still not bad at all. It was about 0.97, and I thought it was about 0.99. Okay, one more, just to check your intuition. Pause and try out tangent of negative 0.4. Okay, so negative 0.4, again, our reference point is that this is about negative 1.57. So what, pi over 6 is kind of in the ballpark of negative 0.5. It's a third of that, so it's about negative 1/2. So it's not quite the pi over 6 mark. So maybe something like this for our third point P. And we were supposed to estimate tangent, and tangent is slope. So let's see if I can even begin to draw somewhat of a straight line down to there. Very far from perfect. So you could do this by trying to trust your line, which I don't very much, or you could try to estimate your x and your y. So it looks to me like my x is about, what is that, 0.9, maybe about 0.92. And it looks like my y is, okay, that would be negative 0.4. And this is negative 0.35, so maybe like negative 0.36 or 7. Okay, so we want to do y over x. So I'm going to do a negative 0.36 over 0.92. And I got about negative 0.39. Okay, and then let's check and see what the actual value is. There we go, my Zoom wasn't working. Okay, so we want to know what is the tangent of negative 0.4. And I got about negative 0.42. So again, not too far off, negative 0.39, negative 0.42. So just remember, your arc lengths do not have to be special values. They don't even have to be multiples of pi. And these things should make sense. You should be able to look at your unit circle and kind of say, okay, does it make sense that my y coordinate is almost 1 or my x coordinate is almost 1? Does it make sense that my slope is kind of in the ballpark of negative 1/2? All right, thanks for watching.